Hello. Today I'm just gonna share a little bit of experiment that my students and I did. Uh, we are just exploring materials and seeing the potential of materials. So in this experiment, they were trying to see what uh, they can use eggshell for. So these are fired eggshells. Okay. It's been fired to 900 degrees Celsius. So if you crush them, it becomes powder and calcium carbonate, I guess. Kinda. Yeah. So that's another one. And then this one is the eggshell. It's wedged into the black clay body, and then fired, and then glazed, and then fired again. So if you can see all these crumbs coming out, what happened, it's kind of similar to how everybody keeps saying that you're not supposed to mix plaster into your clay. You will contaminate the clay and make it fall apart. Yeah, so that's what's happening here. The eggshell that turns into calcium carb when it's being fired, the white specks here, is prone to soaking up moisture from the air and everything else, and then it expand or contract, right? Which makes the clay that's brittle after it's fired not stable. So things are like crumbling apart, falling apart, right? So that's one of the reasons why most potters are very wary of contaminating their clay with plaster, which basically what's happening here. The eggshell become plaster, and then now it's embedded into the clay. So, and then when the moisture comes in, it'll expand and contract, and making it like that. And the funny thing seems to be very crumbly where it's glazed, but not so much when it's not glazed. See, in the bottom part where it's not glazed, it's slightly stronger, like it's not as crumbly as the part that's glazed. Okay. Be careful with this stuff, it's quite sharp because it is have glaze on it also. And then another test that I did, that my students did, is making a pinch pot out of the black clay and then sticking the eggshell, not as in powder form but just in chunks, onto the surface and firing it. So you can see the marks that's left behind by the eggshell on the clay, which is quite a nice pattern, especially on the inside. And then after it's being fired, we brush off as much as we can all the leftover eggshell, or now become calcium carbonate, and then as cleanly as possible, so nothing is left behind to make the clay crumbly. And then we put white shiny glaze on it and rub it off, so the white glaze only left in between the cracks and the indentations left behind by the eggshell. And then I dip the whole thing in transparent glaze and fire it. So you do get this very cool pattern, which is it's a great decorating technique. Kind of slightly tedious, but for the result that you get, I guess it's quite unique and quite valuable, right? And it has no problem flecking off because we clean off the whatever eggshells left on the clay really good, right? And nothing get embedded into the clay itself. It was only on the surface. Then the crushed eggshell that's been fired, this is another test. We grind it down into really fine powders and then mixing it into transparent glaze. and see if it behaves like just like calcium carbonate that you can buy from a ceramic store. So this is without, just transparent glaze without the eggshell that's been fired, and this one has been mixed with the eggshell, and you can see it is kind of slightly matting, and it's fired to 1100 degrees Celsius. From what I understand, calcium carbonate at a higher temperature become a flux also, but below, at a lower temperature like 1100, it's not a flux yet, so it usually becomes a slight matting agent. Right? It has a slightly rough surface, so if you grind it even finer, probably you can get quite a nice satin glaze. This one has been applied all over, so some part has, I guess, more eggshell and some part doesn't. The one that didn't still remain quite shiny, and the part that has more eggshell in it, I guess, becomes slightly more matte. Okay, I guess that's what I want to share today. Hopefully that's interesting to you as it's interesting for me, right? If you ever wonder what you can do with eggshell, so that's our experiment. Thank you for watching. Bye.